of 3 times a first number and twice a second number is 8. If the second number is subtracted from twice the first number, the result is 3. Can anyone help with this? If the second number is subtracted, from
minus y.
Very good. The result is 3. Excellent. Good. We have a system of 2 equations, 2 variables. We will be able to get one of these situations. Either one solution, no solutions, or infinitely many. Good. Now, I noticed 3 and 2. No. I noticed 2 and -1. Yes. I will multiply the second equation by. I'll copy the first and multiply the second equation by, because my intention is to eliminate y.
2.
Excellent. So this will be 4x minus 2y equals 6. Careful, we do not pick and choose. We multiply everything by 2. According to plan, y goes away. I see 7x and I see 14. Lucky me, x equals 2. Good. Let's say I go back here. 2 times 2 is 4. 4 minus y equals 3. I move 4 to the other side. It becomes negative. Careful. -4 plus 3 will be -1. I have to divide or multiply and get equals 1. Y equals 1. So the solution appears to be always x first, y second, 2, 1. Do I trust this? No. I go back and check. It takes a few seconds.
Trust but verify.
Say it again.
I said trust but verify.
Yes. Excellent. Yes, that's wonderful. I love that. I'm going to borrow it. Trust but verify. Excellent. Thank you. It was Samantha?
Yeah.
Well done. I agree.
Well.
3 times 2 is 6. 6 plus 2 is 8. Yes. 2 times 2 is 4. Minus 1 is 3. Yes. Only now I'll say yes. I checked. Questions? Questions?
I don't have any.
Okay, moving on. The next section that we need to cover is 5.3. I'm trying to find the page for you. Okay. Not 5.3, I'm sorry, 5.4 and 5.5. Okay. I'll give you the page in a second. Okay. Okay. All the same, but nonlinear systems now. And this is my page 5. .4. I'll tell you the page. 590. No, 5. Page 587. Systems. So 587. Systems of non-linear equations. Here the options are multiple. So I don't have a recipe for this one. Like I had a recipe for systems of two linear equations in two variables. This is the recipe. This, or this. But here I don't, because there are too many different options. Okay, so let's start and see what we mean by that. Okay, we're going to still look at substitution and elimination. So I'll choose the first one and you'll choose the next. So for example, number 8 on 587 is x squared plus y squared equals 5 and 3x minus y equals 5. Why is this a non-linear system? This is a linear equation, but it is not linear. Does anyone remember how does this look like? What is this? I can give you a hint on the side. That's my hint. What is this?
Circle.
Yes, it is a circle with centered at the origin and with a radius of the square root of 5. So how will this look like? We're not going to need to graph, but how will this system look like? This is the circle. I didn't correct the graph anything. I didn't show you any units or anything, just a circle centered at the origin. And this one, let's say, is this line. So what do you expect? It could be this line, only one point. But this time you will see that if this is the situation, I don't know, I just picked the problem. Obviously, we will have two ordered pairs that verify the system, not just one. Because the circle and the line could meet twice, could also meet only once. It's possible if the line is tangent to the circle. Or not at all, of course. But these are multiple possibilities, so we're not going to graph. We're just going to go ahead and discuss what we can do. Obviously, x squared and x are not the same variable. You can say it's the same variable, but this is x squared and x are not like terms. Same thing here. This method, the method we have to use here must be substitution. I can only use the elimination method when terms are like terms. I was able to add 3x to 4x. I was able to add negative 2y with 2y. But here, no matter what I do, no matter what I multiply by, I will not be able to add. They're not like terms. Of course, I will not touch this one, because if I want to solve for x or y, I will have a square root. No. Of course, I will not solve for x, because the coefficient of x is 3. So my only chance is to solve the second equation for y. Of course, first for negative y. So negative y equals negative 3x and plus 5. Yes, I will divide or multiply by negative 1 to solve for y. So then y equals this times this will be 3x, and this times this will be negative 5. And I have now to go to the first equation and replace y with this. So I copy x squared plus, in parentheses, I write 3x minus 5 squared, and that equals 5. And as you know, I'm kindly asking you to remember this always. I have to square binomial. If I only write two terms, I mess up the problem. When I square binomial, I have to have 3 terms. Okay, so x squared plus the first term squared minus 2 times 3 times 5. When I multiply 2 times 5, I get 10. 10 times 3 is 30. And plus the second term squared. Of course, it's quadratic. I have to move 5. I will combine like terms. I have x squared plus 9 squared, so this is 10x squared. The negative 30x will stay, and this is positive 20. And as I mentioned many, many times, this should always be in the back of your mind. Of course, I'm going to divide by 10. I don't want to work with these numbers. So then I have x squared minus 3x plus 2. Now this is clear. It's x minus 1 and x minus 2. So I found my two solutions. And you can say not so fast because you didn't determine y. I agree. But it's this kind of situation where the circle is cut by a line into different points. I know it's not done. I haven't even checked or anything, but I know the solutions are there. So then, two ordered pairs. X equals 1, and let's see what we get for y. When x equals 1, 3 minus 5, negative 2. When x is 2, 3 times 2 is 6, minus 5 is 1. Does this work? I have no clue. I can only hope. I go back to the original system. And 1, negative 2, 1, negative 2. 1 plus 4 is 5, yes. 3 plus 2 is 5, yes. And then I'm checking 2 and 1. 4 plus, yes, correct. And 2 times 3 is 6, minus 1 is 5. Yes, I'll say yes, I'll say yes. Yes, in some situations, we can use elimination or the adding method, but only when we have the same variables with the same power. We do have the same variable, but we have to also have the same power. So, for example, let's look at 27 caught my eye on 587. We have y squared minus x equals 4, and x squared plus y squared equals 4 as well. Look at that. First of all, I notice that I could use a substitution right away. Moving x, so I have x equals y squared minus 4. But let's use the adding method or elimination. First of all, I have to have everything in the correct order. Terms with x, terms with y, equal symbol, free term. This is okay, but this is not. So I will write negative x plus y squared equals 4, and x squared plus y squared equals 4. I could not eliminate x. They're not the same. I will not be able to get rid of this, but I'm able to get rid of this. And I have to multiply one or the other by which number to eliminate y squared. I think I heard somebody say negative 1. So I have x minus y squared equals negative 4, and then x squared plus y squared equals 4. Now this is prepped for exactly what I wanted to do. So this is another aspect that we need to make sure it's clear. Terms with x, terms with y, equal symbol, and a free term. So on this side I have 0, but on this side I cannot add them. They have to stay as x squared plus x. But that's not a big deal. I will factor out x, get x plus 1, and then I get two solutions. As x equals 0 and x equals negative 1. If I determine x, I should be able to determine y. Not necessarily, but I should be. Okay, so x equals 0 means y squared equals 4, which we know has two solutions because we will take the square root, and we will not forget to write plus or minus 2. Okay, we go back now and replace x by negative 1. So it becomes y squared plus 1 equals 4, or y squared equals 3. When I take the square root, I get plus or minus the square root of 3. In this case, look what happens. When x is 0, I could get positive 2 or negative 2. When x is negative 1, I could get the square root of 3, or I could get negative the square root of 3. 4 solutions, 4 ordered pairs in this case. Any questions? Is this true? Yes. X squared, this squared plus this squared is 4. 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 And this is what happens with nonlinear systems. Anything can happen. I don't have, as I said, a recipe. It depends on what we are looking at. Okay. Let's look at a word problem here, or if you'd like to work on more, please tell me and please choose. Are we ready?
Number 10.
Sorry, say it again.
Can we do number 10?
Yes, of course. Number 10. What does it say? 10, 10, 10. Yes. So number 10 on 587 says xy equals negative 12 and x minus 2y plus 14 is 0. Perfect. There is no discussion here of elimination. There is nothing I could eliminate. I have a product of xy. I don't have a product of xy here. This is a line. This is something else. So I can only think of substitution. I can substitute for either x or y dividing by one or the other. But this is a better bet. Moving these to the other side. So I solve the second equation for x because x has coefficient of 1 or negative 1. In this case is 1. So I get 2y minus 14. I will replace this in the first equation by 2y minus 14. Very good pick. Thank you. So 2y minus 14 multiplied by y equals negative 12. I know how to solve this. I have to distribute, move everything to one side because it's quadratic, and solve. So this is 2y squared minus 14y plus 12 equals 0. You know me. I will divide immediately by 2. Y squared minus 7y plus 6 equals 0. I will factor y minus 1, y minus 6 equals 0. I get 2 solutions for y. I will be able to find 2 solutions, 2 numbers for x. So when y is 1, 2 minus 14 is negative 12. When y is 6, 2 times 6 is 12 minus 14, x is negative 2. So it appears negative 2, 6, negative 12, 1. And of course,